Hello, and welcome to section 5.2, day 1. So in the top corner, we're going to put our name, date, and we're going to say 5.2, day 1. And on the top of our paper, we're just going to say, solve systems of linear equations by substitution. Okay, so we're going to use substitution today. All right, to start off, we're going to fold our paper in both hot dog and hamburger way. You can see I already did that here. Our first two boxes up here are going to be steps to solve these systems, and then we'll do some examples down below. All right, so when we have a system of linear equations and we want to solve it using substitution, our step 1 is to solve one of the equations for one of the variables. All right, so we could solve for either x or y if it's a normal x and y equation. So we're just going to solve for one of them to start off. All right, and then we're going to follow the next step. So step 2 is going to be substitute the expression from step 1 into the other equation and solve for the other variable. All right, so for example, in step 1, if we solve for x, we take our equation, we plug it into the other equation, we would solve for y here, okay? All right, and we'll go through with some examples and you'll see it, and I can explain the steps as we do it. Step 3 is to substitute the value from step 2 into one of the original equations and solve. Okay. All right, step 4 is going to be write your answer from steps 2 and 3 as an ordered pair. All right, and just remember, we'll write that as x, comma, y. All right. So we're going to go through these steps. Today we're going to have it so they're always going to have a variable equal to it. So it's going to be either x equals or y equals. Tomorrow we'll have to solve for the variables. Okay, so our example here that we're going to do is we're going to solve the following using substitution. All right, so that's going to be the examples for all of these here. All right, example 1, we're going to have y equals negative 2x minus 9, and we're going to have 6x minus 5y equals negative 19. Okay, so step 1 tells us that we need to solve for one of the variables. The nice part about this is, in our first equation here, the y is already solved for. So what we're really going to do is we're going to substitute this value here into the second equation for y because it's y equals. So this will now become 6x minus 5 times negative 2x minus 9 equals negative 19. And I tried to color coordinate so you could kind of follow here. All right, so step 1, we solved for the variable. It's already done for us. Step 2, we took that expression and substituted it for the other variable, or for the variable it's solved for in the second equation. All right, and now we're going to solve this. So we'll have 6x. We're going to distribute the negative 5. So that'll be plus 10x. Negative 5 times negative 9 is 45 equals negative 19. Okay, so we would now combine our like terms. So we would now have 16x plus 45 equals negative 19. We're solving for x here. So we subtract 45 from each side. So we'd have 16x equals negative 64. Okay. In order to get x by itself here, we're going to divide by 16, and we'll end up getting x equals negative 4. Okay. So once we have x equals negative 4, all right, that's step 2 being done. Now we need to go to step 3. So we're going to substitute this into either of the two original. I always like to pick this first one here because it's already got the variable solved for it. So we would say y equals negative 2 times negative 4 is 8. 8 minus 9 is 1. 8 minus 9, sorry, is negative 1. So our solution, and to write as an ordered pair, would be negative 4, negative 1. Okay? So those are the steps we're going to follow for each of these problems. Okay? Example 2, we have x equals negative y plus 3. And our second equation is 3y plus 5x equals negative 1. All right, so we're going to look. Is any of the variables already solved for? Well, the nice part is, once again, it says x equals this value right here. Okay, so what we're going to do is we're going to substitute that value in for, notice it's x equals x in the second equation. So we would now have 3y plus 5 times negative y plus 3 equals negative 1. So now notice here, the only variable we have is y. When we only have one unknown, we can solve for it. So now we would go through and do the same thing. We would now distribute the 5. 5 times negative y is negative 5y. And 5 times 3 is 15. We're going to combine our like terms. So we'd have negative 2y plus 15 equals negative 1. We're solving for y here, so we subtract 14. Sorry, we subtract 15. Sorry, that's my bad. So we subtract 15. So we'd have negative 2y equals negative 1 minus 15 is negative 16. And now we would divide by negative 2 to get the y by itself. And we get y equals 8. All right, so now once we have y equals 8, we're going to plug that in to one of our original equations. I'm going to plug it into this first one here. So I'm going to say x equals negative 8 plus 3. Negative 8 plus 3 is negative 5. So we got our ordered pair that's going to be negative 5, comma 8. Okay. All right, if we flip our page over, we'll do 2 more examples as a group, and then I'll have one that I'll have you guys try on your own. All right, so example 3 is going to be y equals 3x plus 14. And the second equation is y equals negative 4x. Okay. Now the nice part about this one is it doesn't matter which one we plug in here, because notice they're both equal y. So if I stay the same thing and I say, well, I'm going to plug this value here into y in the other equation, I would now have 3x plus 14 equals negative 4x, right? Because that's what y equals, so I plug it into that one there. Now, we don't even have to distribute anything here. All we need to do is solve for x. So to get all the x's on one side, I would subtract the 3x. So that would leave me with 14 equals negative 7x. We want to get the x by itself, so we're going to divide each side by 7. So negative 2 equals x. Okay, so now once we have our x, we can plug it into either of the two original equations to get our y. I'm going to plug it into the second one, and all I have to do is negative 4 times negative 2, which is 8. And then I got my solution point, which would be negative 2, comma, 8. That's my solution. And you can write solution if you'd like. It doesn't matter, okay? But just make sure you please write it as an ordered pair. All right, so our next equation that we're going to work on together is example 4. It's going to say 4x plus 3y equals negative 5. And our second equation is x equals y minus 3. Okay, so when we do this, all right, our first equation doesn't have any variable solved for, but our second equation does. The x is solved for here, so we have x equals y minus 3. So this value is now going to get substituted into x in the first equation. So we now have 4 times y minus 3 plus 3y equals negative 5. Okay, so notice we substitute this value in. We distribute the 4. 4 times y is 4y. 4 times negative 3 is negative 12 plus 3y equals negative 5. Okay, we're going to combine our like terms. 4y and 3y is going to give us 7y minus 12 equals negative 5. We're solving for y, so we're going to add 12. So we'll have 7y equals 7. We'll divide each side by 7, and y equals 1. Okay. Now we're going to plug it back in to one of our two original equations. Right? I like to plug it into the one that's already solved for. So we'd say x equals 1 minus 3. 1 minus 3 is negative 2. So our solution is going to be negative 2, comma 1. Okay, so that's the last example we're going to do as a class, all right, or together. What I'd like you to do, I would like you to try example 5, all right, to add to your notes before you submit it. Example 5 is 4x plus y equals negative 3. And our second equation is x equals 6y minus 7. Right? That's the end of the video for today. Please make sure you complete example 5, all right, to continue with your notes. Follow directions, whatever we ask of you to submit. Have a great day. Please know we're here if you have any questions. We'll talk to you soon. Bye-bye.